So in the neuron, we have all sorts of organelles. So we have, a lot of the same organelles you would see in any other neuron. You have the nucleus, ribosomes, or not ribosomes, but rough endoplasmic reticulum, which contain ribosomes. You have Golgi apparatus. You have mitochondria. And then we talk about the dendrite. There can be a lot of cells. We'll just talk about different kinds of cells in a little bit, but a lot of cells are called pyramidal cells. They look like little pyramids, and you have one big dendrite that comes off, and then you'll have little smaller dendrites which are coming out the sides. And these will be the apical dendrites because they come out the apex of the pyramid, and basal because they come out the base of the pyramid. And then you have the axon, which there is actually in this area right here near the tip of the source of the axon is called the axon hillock. So that's the axon hillock. And the axon hillock, to generate all of these action potentials, we have ion channels which open and close, and it turns out there's an unusually high density of ion channels here, and it turns out the properties of the ion channels are a little bit different at the axon hillock, so that it's actually likes to spike a little bit earlier than other places on the cell. So it will start an action potential here and then travel down. And it won't just travel down. So this is the anterograde direction. It starts here and travels down. If we put an electrode and stimulate here, we're going to get anterograde and retrograde propagation of action potential. But here at the axon, it will go down, but it also will travel up into the dendrite. And that will change a lot of things going up on the dendrite and change the sensitivity of these synapses to other inputs. And we'll have so that's called a back-propagating action potential. And so action potentials don't just go straight down. They go both directions. All of these things, generally we think of as the ion channels get opened by neurotransmitters here. Then you get small depolarization, and that depolarization sort of travels down. And a bunch of them summate and bring essentially these channels up to threshold. And then you get this sort of positive feedback loop, which gives you sort of an all or none response. And that all or none response really starts here. And you don't really get an all or none response up in the dendrites because there's generally not that many. There is some active sodium channels up there, but not enough to really generate. You can also get calcium spikes. It gets very complicated very quickly. But if we just sort of think of the canonical cell, this is where the action potential will start. And it generally will go as a all or none response traveling down the axon this way. And you will get a more graded response. The voltage will travel back up, but you get smaller and smaller the further you go back. It's much more passive up in the dendrite. A lot of these axons will be myelinated, and so you'll see the myelin, which covers and insulates the neurons. And we'll talk about how the myelin works and saltatory conduction.